Okay, so then the next thing I'd like to discuss, now that we're discussing IO management and the IO API inside of Java, is, well, we've talked a little bit about what the IO package is all about. And we've talked a little bit about the concepts that drive what a stream is, and looked at the stream basics. The next thing I'd like to do is actually look at the stream classes that are defined in Java so that we can start understanding how we can use these streams in practice. And so here, let's take a quick let's take a quick overview of what we're going to cover in this presentation. So a quick introduction into the stream classes, and then we're going to really focus in on byte streams and character streams. And then we'll talk about byte streams in Java. Then we'll talk about character streams in Java. Then we'll talk about the stream classes. And then we'll talk about the byte stream classes. Then we'll talk about the input stream classes and the input stream methods and the output stream classes and the output stream methods. So a quick introduction: streams in Java represent an ordered sequence of data. Java performs input and output operations in terms of streams. It uses this concept of streams to make IO operations fast. For example, when we read a sequence of bytes from a binary file, actually, we're reading all of that from an input stream. Similarly, when we write a sequence of bytes to a binary file, we're writing that to an output stream. So let's talk about byte streams and character streams. The modern versions of Java platform define two types of IO streams: byte streams and character streams. So let's go ahead and kind of walk through each one by one to kind of identify what those are, what the distinction is between them. So with byte streams in Java, they're designed to provide a convenient way for handling the input and output of bytes. And so when I say bytes, they're units of 8-bit data. And so you'll learn much more about bytes probably in assembly, which you might be taking this semester, maybe you're not, but you'll definitely cover bytes in much more detail there. But just understand that a byte is the smallest addressable space in memory. So if a bit is a single binary unit, right? So a bit is the smallest unit of digital data that exists, but in actuality, you can't address into just a single bit. Bits are grouped into a collection of 8 for one address, and that's what a byte is. So the smallest addressable space in memory is a byte. And so all your data types are then defined based off of how many addressable bytes they take. And so we use them for reading or writing to binary data. So byte streams are especially used when we are working with binary files, such as executable files or image files, files in low-level formats, such as .zip files or .class files, or in like or .obj files or .exe files. Like, all of these are files that if you were to open them up, you wouldn't be able to read because they're not designed to be read like a text file, right? They're storing the data in a very compressed way in binary formats that special applications require to be able to parse and then use. Like in an executable file, it's used to run an application. In an image file like PNG, it's used to then render out and display an image using a special application. So these are all they're not designed to be human readable. So binary files are those that are machine readable. So byte streams that are used for reading are called input streams, and for writing are called output streams. They're represented by the abstract classes InputStream and OutputStream in Java. So for example, a Java class file is an extension of a .class, right? We've seen this plenty of times. Every time we go to compile our .java source code files, which are human readable, right? They're composited of characters but then when we compile them, they become unreadable. Humans can't read those. So it can be processed by low-level tools such as the JVM. So the JVM can execute those .class files because it's designed to parse that binary format and be able to then read those instructions into its application and do something. So for instance, if we were to take this Java application and suppose we then convert it into a .class file, well, the .class file would look something like this. It would just be a collection of binary data. And so this binary data that you're seeing in here is in like a disassembler. So it's being conveyed in terms of a hexadecimal format, but at the end of the day, it's all just zeros and ones effectively. And if we try to reconvert this, you could see it actually retranslates back into the machine instructions that the JVM would use to go ahead and execute this. So just an illustration that when we create a .class file, this is effectively the format that we're doing. It's a binary, it's not a text file, it's a binary file format. And just another real-time example is like whenever we store a photo in like a bitmap or a JPEG or something, effectively you have an application that's defining how to compress that data so that it can then be reconstituted back into the image. So in this instance, suppose that each of these color values in a particular position is encoded with a binary value, so 00 or 01 or 10 or 11, and then it gets compressed across the bitmap. So it would be 101010101010. And so if we remove the actual pixels and just looked at the binary representation, we could see how we can map from images to binary data. And again, this is just a quick explanation of how things are encoded in binary for applications to be able to compress and then decompress or reconstitute them back to their original form, or use them to drive an application, right? It has your instructions. So whatever the application is designed to do, all of those instructions are embedded as binary. So let's go ahead and distinguish that from the character streams in Java. So a character stream in Java are designed for handling the input and output of characters. They use 16-bit Unicode characters. So so let's distinguish that. We said that for a byte stream, the smallest addressable space was 1 byte. That's 8 bits. But Unicode characters, the characters we use to be able to encode all of our text, is 16 bits, which is 2 bytes. So already you could see there's a distinction between how we're going to tokenize those streams, how we're going to be able to read from those streams, where with a byte stream, you could read a byte at a time. Clearly with a character stream, you'd want to be able to read 16 bits, 2 bytes at a time. So character streams are more efficient than byte streams. They're mainly used for reading or writing to character or text-based input-output, such as text files or text documents, or XML. XML is short for extensible markup language documents. Those are effectively configuration files. So if you open up, say, for instance, the .iml file inside of IntelliJ, which defines all the configuration information for your Java application, you'll see that's a lot of like tagged instructions. That's an XML file. So it's a way of defining or serializing instructions to provide metadata and data in one document using characters. And then you also have HTML files, which are hypertext markup language. Those are the files of the internet, of most web pages. So that's usually gets shared by HTTP servers. And in fact, that's the file format that your Java docs are in, right? So when you open up your Java docs and you can go ahead and display them in a browser and be able to hyperlink between them, that's because they're formatted as HTML documents. So text files are those files that are human readable. So for example, a TXT file that contains human readable text would be one that we'd want to use a character stream on. So this file is created with a text editor such as Notepad, or we could do it with any other kind of text editor. You can even make text documents with IntelliJ if you wanted to. Character streams that are used for reading are called readers, and for writing are called writers. So before, when we looked at output streams and input streams, those are used for bytes. Readers and writers are used for characters. And again, those are going to be represented by the abstract classes of reader and writer. So already we can now start to expand our concept of those 4 core classes of the IO classes that Java has, based off of whether we're trying to read bytes, read characters, write characters. So the stream classes in Java, so all streams in Java are represented by classes in the java.io package. The package contains a lot of streams that provide the abilities for processing all types of data. So here we can classify these stream classes into 2 basic groups based on the data type, right? So if we have all our most abstract form of our stream classes here, we can say, oh, well, there's going to be byte stream classes and there's going to be character stream classes. And inside of our byte stream classes are going to be the input stream classes and the output stream classes. Whereas with our character stream classes, it's going to be reader classes and writer classes. So again, these represent support for handling IO operations based on bytes, whereas these will support any IO operations based on characters. So for the byte stream classes in Java, there are 2 types, as we've mentioned before, the input stream and the output stream. But now you understand what the parent class is effectively for in this instance, right? It's for reading bytes. So for the input stream classes in Java, input stream class is an abstract class. So it's the root class for reading binary input and output. It is the superclass of all classes representing an input stream of bytes. So since input stream class is an abstract class, we can't directly instantiate an object of it. So we have to use a subclass in order to create an instance. So there are several subclasses of the Java input stream class that we can use to perform several input functions. And so here, just so that you can see them, and again, we'll walk through these in more detail later. Right now, this is just effectively an overview, but we have the buffered input stream, and this is used, it adds buffering abilities to an input stream. In simple words, it's a buffered input stream, hence the name. We have a byte array input stream. This is an input stream that reads data from a byte array. We have a data input stream. This is a input stream that reads bytes from the input stream and converts them into the appropriate primitive type values or strings. We have a file input stream. This is an input stream that reads bytes from a file. We have a filter input stream. This filters bytes from an input stream. And so there's a ton of subclasses for our filter input stream that define how you might want to filter those bytes. You have an object input stream. This is an input stream for objects, for in-memory objects, for Java objects. You have a piped input stream. This creates a communication channel on which data can be received. You have a pushback input stream. This is a subclass of filtered input stream that adds pushback functionality. And then you have a sequence input stream. This is used to read input streams sequentially, one after the other. So the abstract input stream class in Java also obviously defines several methods for performing input functions, such as reading bytes, closing streams, marking positions in streams, etc. So all these methods are present inside of the java.io.inputStream package. And the inputStream methods are as follows. And again, these are the methods for inputStream. So all subclasses would inherit these methods. So we have the ability to read, and that's going to return back an int. So the read method reads the next byte of data from the input stream, and then it returns the input byte read as an int value to the range of 0 to 255. So again, what you're reading is a singular byte. A byte is 8 bits, and that's effectively an 8-bit sequence can be converted into a decimal representation, and that decimal representation can be anywhere from the number 0 to the number of 255. And so the idea is that you can parse that sequence of zeros and ones, and it could be any number between there. So if no byte is present, because the end of the stream has been reached, then it will return a negative value, the value of -1, to illustrate that there's no more bytes left. So that's a way of saying you've hit your end of file, or you've hit the end of input, or the stream is empty. If this method occurs, an IO error will be thrown, IO exception. The read method returns as an int value -1 instead of a byte because it indicates the end of the stream. Okay, so we also have read, but with a parameter where you can pass in a byte array. So this method reads the number of bytes from the input stream and stores them into the array of bytes that gets passed into it, as opposed, and it then returns the total number of bytes read as an int. So again, if the end of the stream is reached, it returns a -1. So the difference between these two is this is returning back the actual byte value for a singular, for a reading of 1 byte, where this you can pass in an array and it'll put all of what's read into the array. And then the thing it's returning back is how much it read into the array. Then we also have another read method where you can pass in a byte array and then 2 parameters, an m value and an m value, both represented as integers. So this reads up to m bytes of data from the input stream, starting from the nth byte. So the n represents your starting position, the m represents how many bytes you're going to read, and then you're going to read all of those and store them into the byte array. And then the value that gets returned is the total number of bytes that were read in as an integer. And then again, you're going to return a -1 if you had encountered the end of the stream because there was no more data, to let you know that you can't read any longer. We also have a method available. The available method returns an estimate of the number of bytes that can be read or skipped over from the input stream. We have a close method. This close method closes the input stream and releases any system resources that are associated with it. We have a skip method where we can pass in not an integer, but it is an integer type value that is encoded as a long. So it can be a very big integer number. So this method skips over n bytes of data from this input stream. It returns the actual number of bytes that are skipped. We have a reset method. This reset method is used to go back to the beginning of the stream. And we have a mark supported method. This returns back a Boolean value. And this method tests the input stream supports the mark and reset methods. It returns true if the input stream supports mark and reset, and false if it doesn't. Okay, for output streams, so output stream class is an abstract class. It is the root class for writing binary data. It's a superclass of all the classes that represent an output stream of bytes. Since output stream is an abstract class, we cannot directly create objects of it. The hierarchy of classification of output stream classes is shown in the diagram that I showed earlier. So I guess we can go back if we want to see here, right? Well, I guess I can. There are several subclasses of output stream that we could talk about. And actually, why don't we just jump to that so we can see what the subclasses are. So we have a buffered output stream. And so notice a lot of the input stream classes have comparable output streams. So we have a buffered output stream. It has buffering abilities to an output stream. We have a byte array output stream. This is an output stream that can write data to a byte array. We have a data output stream. This converts a primitive type values or strings into bytes and outputs bytes into the stream. See, so we have ways of writing to byte arrays, which we've already seen that there were read methods that do that. We have the ability to convert easily between our streams and our primitive types, and now from our primitive types back into our streams as it's encoded as bytes. We have a file output stream where it writes byte streams into a file. We have a filter output stream where it filters bytes from an output stream. We have an object output stream, which is an output stream for objects, for in-memory objects. And then we have a piped output stream where it can create a communication channel on which data can be sent. So our output stream methods in Java, well, output stream class defines the following methods in the java.io.outputStream package, and they're used to perform all of our output tasks, such as writing bytes or closing streams or flushing the streams. And so the output stream methods descriptions, just really a quick overview, is inside this table here. So I have clearly for the output stream the ability to write, and I can pass it in an integer value b. So the write method writes the specified byte to the output stream, and it accepts an int value as an input parameter. And then again, if it's going to represent it as a byte, it'll then encode that into its binary form. It throws an IO exception if an IO error occurs, e.g. the output stream has been closed and you try to write to a closed stream. You can't do that, right? Because it's been deallocated. You also have the ability to write and then instead pass it in a byte array. And again, byte is, I don't know if this has been covered previously, but byte is a primitive data type in Java, just like int or double or Boolean. So this method writes all of the specified bytes in the byte array to the output stream. We also have another write method, but this one has 3 parameters where we can pass in a byte array. Then we can pass in 2 int values, one that is n and one that is m. And again, the n represents a starting point and the m will be the number of bytes to read. So it writes m bytes from the byte array starting from the nth byte, starting at the index position of n into the output stream. We have a close method. It closes the output stream and releases any system resources associated with the stream. And finally, we have a flush method that flushes all of the output stream and forces any buffered output bytes to be written out. So it's important to understand when we're passing things into a stream, it's not necessarily going directly into the source. It can be getting buffered into the stream, and the stream decides when it's then going to move the data from the stream into the actual destination. So if you want to effectively flush everything from the stream into the destination, there's a flush method to force it to write to the destination. And that's usually an optimization thing, because Java usually decides when things get actually written to the destination. You just worry about writing things into the stream. Excellent. And so that's just a quick overview for the stream classes in Java. Does anyone have any questions about those Java classes? And again, we haven't really used any of these in practice yet. We will soon, but I really want to just ensure that everyone has a strong foundation of these principles of input and output, because we've kind of abstracted these away in the earlier class. And so now you're really getting a great sense on how Java is modeling input and output, and then how they're implementing based off of those models. And this is a pretty consistent model across all of their programming languages. So once you kind of get a mastering understanding of this in Java, the same way you would import and export data from a Python application or a C++ application or a C# application or a JavaScript application would be very similar.